Inequalities graph very much like equations do, linear equations, and these are all linear inequalities. So one of the things that you can do is to make a chart and pick values and then find some points so that you can graph it. Now in this case, we have our x and y. Usually we pick x's and then solve for y, but since this one has an x greater than negative 5y, it would be easier to pick values for y and see what x is equal to there. So I'm going to pick a couple of values for y and then see what x would be equal to there. Now in this case, notice that our inequality is strictly greater than, so when we graph, we're going to choose the tool over here that has the dotted line, because those are our boundary points and those numbers don't actually work. They're not a solution for this, but they just show where we can get up to. So if I pick, say, -1, 0, and +1 for y, I'm going to see what I'll get for x. So x is greater than -5, and remember I'm going to replace my y with -1 to begin with. So I have x is greater than +5, -5 times -1. So I have 5, -1 for a point. If I substitute in 0 for y, x is greater than -5 times 0, which is just 0 for my x. And then if I substitute in +1, and you could write these with equals instead of the greater than symbol, because we're just selecting points. We're finding the coordinates of our points, so that part doesn't matter. We just need to make sure that when we graph it, we use a dotted line because it's greater than. So -5 times 1 will give us -5. So there are 3 points. And you really only need 2, but the third one is good to have to check. So we have 5, -1, which will be here. Go to the right 5 and down 1. We have 0, 0, which is at the origin. And we have -5, +1, which is left 5 and up 1. So there are our 3 dots. And I'm going to attempt to put in my dotted line here. Draw it in. Not a great straight line there, but you get the idea. And with my math lab, it will make a nice straight line for you. Now you have to decide, are we going to shade above or below this line? And you will pick the shading tool, the little bucket, to shade either side. To do that, you need to pick a point on either side of the line and then check it in your inequality. So if I pick a point over here, and you could really throw a dart at it and pick any point you like, but I'll say pick this point. It's that point is +1, +1. So it's definitely above the line. It's not on the line. We don't want to pick a point on the line. So I've got that point. So I'm going to substitute in 1 and 1 for my x and my y into my inequality. So I have 1 is greater than -5 times 1. So I get 1 is greater than -5. And that's a true statement. So if it's a true statement, then I shade that portion, that side of the line. If it had been a false statement, if it had said 1 is less than -5 or something like that, I would have shaded the opposite side. So that's how you graph an inequality. Now on the next slide, I will show you how to graph that type. With this inequality, you can graph it a little bit different. You can go back to the chart where you pick values for either x or y and then solve for the other, but when they're like this, I tend to try the using the intercepts. So for that, you just plug in 0 for x, solve for y, and then plug in 0 for y and solve for x. So if we plug in 0 for x, then what we get is negative y is less than or equal to 4. We could just write equal. Again, we're just finding points for our line, because then we need to divide by negative 1. And with inequalities, if we were mindful of that, we would change the direction of our inequality symbol. Anytime you multiply or divide by a negative, you have to do that. But this is just a boundary point, so a point for our line. So I put in 0 for x, and I found negative 4 for y. So that's 1 point. And I can go over and graph that. 0 for x means I don't go left or right, and negative 4 for y, and I'll end up down here. Now, for the other intercept, I'm going to plug in 0 for y and solve for x. So then I get 2x is less than or equal to 4, divide by 2, and I get x is going to be 2. So my point for that one is 2 for the x and 0 we stuck in for y. So now that's my other point, is 2, 0. So that's it. Now on this one, since it's less than or equal to, couldn't be equal to, we are going to put in a solid line instead of a dotted line. So you'll make sure that you pick your solid line from your tools. And we again need to find out if we should shade the this side or this side. So to do that, again, we just pick a point. I like to pick the origin if it's available, and it is. It's not on our line. It was on the line that we did before, so I didn't pick it. But it's not on our line this time, and that point, the reason I like it, it's 0, 0, so it makes it easy to replace our x and y values and solve. So if I do that, I have 2 times 0 minus 0 is less than or equal to 4. So I get 0 is less than or equal to 4. And that is true. 0 is less than 4. So I'm going to shade that side. If it had been false, I would have shaded the other side. This inequality works exactly like the one I just did. So I'm going to let you try that one on your own now. Remember, you can use the intercepts, plug in 0 for x, solve for y, plug in 0 for y, solve for x. That would be the easiest one to do on this. And then pick a point on either side and check it with your inequality to see if it makes a true statement. If it does, shade that portion. If it doesn't, shade the opposite portion.